So in our current example, I have selected a heat transfer simulation type, which is just conduction in the solid, and then I have to provide boundary conditions on the outside of the solid. So let's look. I mostly just want to look at the user interface at this point and just kind of show you like the methodology here. So what happened when I created a simulation is that it created this tab where my mouse is over here. That says heat transfer. I can change the name of that, by the way. This will be my laser, my steady state laser heating. I'll just call it that. And then when I'm done, I'll click on the save button to save any changes that I've made. So in general, just kind of look over at the left here. The way this is going to work is that like we'll just basically click on our simulation, and then under that, there's like a little tree. Just walk down the tree in order and make sure that everything is checked off. So basically, if you have a green checkbox, that means that at least the simulation doesn't detect any issues. There's enough information that it thinks it'll be able to proceed with the simulation once you get to that point. So just kind of walk down each one of these tabs and make sure that everything is the way that you want it to be. So like geometry, that'll automatically be loaded in from like when you created the simulation based on a geometry, but you can actually change that out. Like you can change out like what you want to do the simulation on. Like I could change that to the quarter bowl. I'll change that back to the spot on bowl, but choose your geometry. It'll generally automatically detect any contacts. So what is a contact? A contact is, so in my current case, my solid model just has one solid part. But in many simulations, it'll make sense to break up your part into multiple parts. You'll have like multiple solid bodies that are in contact with another. So for example, each solid body might represent a different material that's like in your device, right? So if I have, a stack of 10 materials on top of one another, each material will have its own solid part and they'll just all be in contact with one another. So Simscale, like when it's doing a heat transfer simulation, needs to know which parts are touching which other parts and how to treat that. So generally what it's going to do, it's going to detect any interferences or like touching of two parts, and it's going to create a contact between them. As long as you haven't like overlapped the parts so that like they overlap in space, it'll just detect the surfaces where they make contact, and it'll apply essentially a continuity condition that says that the heat flux and the temperature are continuous across that surface. So if anything gets messed up along the way, like which occasionally happens when you have many solids in contact with one another, you may have to go clean up some of like what it auto detects. But that's for a different video. Okay, the next tab down says element technology, so you would click on that, and you could decide what type of finite elements you want. So in the heat transfer one, there are actually two options. So by default, it will have selected automatic, which means, I think it pretty much always means the linear interpolation, but you can choose. So like the thermal mesh could either be first order, meaning a linear interpolation between nodes, or I could use second order elements, for example. Generally, if you don't believe, like if you don't have many millions of parts, I generally try to keep my mesh to like a couple thousand, like tens of thousands of elements. If you just have like tens of thousands of elements, you can get away with a more accurate second order interpolation. If you find yourself using like millions of elements, you probably, for memory's sake, will have to use first order. But whatever. So like you can choose whether you want to use linear or quadratic interpolation for your elements. It doesn't really matter as long as you've got enough elements. All right, so the next tab down is materials. So when you click on that, like it'll let you add a material that you want your simulation domain to be made out of. It's got a bunch of preloaded materials here. Chances are, I mean, like I've done this enough that chances are your material is not going to be there. I'll talk more about like material, like how to set up these materials later, but you can select a material if it's here, or you can create your own material by just like selecting an existing material and then just, you know, modifying the properties that are here to be whatever the properties of your material are. It'll ask you to assign a volume to that material or multiple volumes. So like basically like it wants you to click on the solid parts that correspond to this material. Now in this current simulation there's only one solid, so it automatically detected that, hey, like this has to be the solid that goes with this material because it's the only solid. But if you have like 10 solids, it's not going to do that. Or if you have 10 solid parts, you may have to actually select. I'm going to create a fake material here. I'll just call it fake material. And I'm going to give it a thermal conductivity of 1. For a steady state simulation, the density and specific heat don't matter. So I'm just not even going to bother setting those for now. The next thing will be boundary conditions, right? So there's like a tab for boundary conditions, numerics, simulation control, and so on and so forth. So we'll have to step our way down through all of these things. I'm going to separate these into different videos, so I'll do the other ones. But basically we're going to like keep walking our way down through this until we get to the tab that says simulation runs. Then when we click on that, it's going to actually do the simulation. But we have to basically just walk our way down through all these tabs and set everything up. Sorry, just one more thing about the user interface. So I mostly went through the left column here. I got a little carried away talking about some of these things. Let's look at some of the other tools that are up here. So up in the upper left-hand corner, obviously, is your project name and the ability to share your project, copy projects. In the upper right-hand corner, you can quickly get to your dashboard, other public projects. So like there are many other users on the internet who've created projects. You can go check out what they've done. The forum allows you to post questions to the community, and generally those do get answered, surprisingly, often by the Simscale staff. So if you have a question that you're really having trouble with, it's a good idea to ask that. The geometry tab over here on the upper right corner allows you to quickly select like which solids. So you can select solids if you want to hide something. So sometimes if you have like multiple parts, it's a good idea to like hide one so that you can click on one that's like hidden behind it. So you can use the little eye button that's up there to hide things. There's like a little measurement tool up here to like measure, you know, like let's say, I don't actually think I can do much right now because there's not like multiple parts, but you can figure out like the total volume and total area of stuff, like calculate center of mass, which is not really center of mass, it's really center of volume, but whatever. You can do some like basic measurements. You'll see once we create boundary conditions that these tools up here and we have meshes. You can do things like select volumes, select faces, select edges, hide boundary conditions or like show boundary conditions. We haven't applied those yet, but soon enough we'll have that. And then there are different ways to like render things. This is actually a little bit more powerful once we have a mesh. You can also define what are called geometric primitives. So like you can define points like throughout your domain, cylinders, spheres, boxes. These geometric primitives can be used later, like when you go to create your mesh, you can use them to calculate, or sorry, when you go to create mesh, you can use those as like regions where you'd like the elements to be more fine than in other locations. That's probably about all we really need to say. In the bottom right hand corner, there's obviously like, the ability to, you can click on the faces of that thing to like sort of turn your solid around, sort of tilt it sideways, rotate it in various ways. I assume you're pretty familiar with that kind of stuff just from, doing solid modeling in the past. Sorry, we got a lovely set of fire engines going by. Yay, Spencer. You can, this will make more sense later, but if you have multiple solids, you can actually click on multiple solids at the same time and save like those selections, like of multiple bodies, as like a named set of solids. So like this can help you like click on things a little faster in the future. If you're having any particular problems, there's like a little help button down here where you can message Simscale. I think that it's actually initially managed by a bot unless you have a particularly good question. There's a scale bar at the bottom as well. Okay, that's probably all you need to know about the user interface for now. At least on my mouse, you can zoom into the interface using like the scroll wheel. Depending on what keyboard you have, like the hotkeys for doing panning are a little different. On my computer, Shift and Control allow you to pan. Like if you hold down Shift and Control and then click, you can pan around. Let's see, what else would you need to do? Yeah, and then if you just click and drag, like click and hold, you can rotate things. Those should be all of the controls that you really need. Okay, that should be good enough.